Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll be solving the display problem. It's a matrix problem where we are required to obtain the inverse of this 4 by 4 matrix. And hence or otherwise, we solve the system of equation. Of course, as you can see, the coefficients of the system of equation is just the same as what we have for this matrix. So it means that the inverse of the matrix can be helpful in solving that system. So, I mean, this kind of question is a very, some students can waste time, unnecessary time on this thing, right? On this kind of question, because after looking for the inverse, they could then go ahead and start solving the problem from the scratch. But a smart student will just use the inverse to solve the problem because I mean in one of my previous videos on that matrices, if you have not seen my videos on matrices, you can check, subscribe, hit the notification bell, and then check up the old videos, and then you can always get the new videos I come up with. So they have treated comprehensively matrices from for different topics of matrices, right? So a smart student would obtain the inverse and use the inverse to solve the problem instead of solving the problem from the scratch, because hence or otherwise means from what the inverse you have obtained, solve this problem. If you don't want to use that, then you can solve the problem in your own way. So, but the smart person would get the inverse and use it to solve this. And that is exactly what I'm going to do for this question. So obtain the inverse of this, and from whatever you get from there, use that to solve this system of equations. And it's a 4 by 4 thing. First of all, there are different methods. I've taught like 4 different methods for obtaining inverses. It can be, the first one is the minors and cofactors method. You can use that. You can also use you can do the Gauss-Jordan method. You can use the Cayley-Hamilton method. You can also solve simultaneous equations. But the trouble is, once a matrix is more than 3 by 3, it becomes pretty difficult to use other methods apart from the Gauss-Jordan method. And that is why I advise, once you are dealing with a matrix that is more than 3 by 3, just stick to the Gauss-Jordan method. As tricky as it may be, it is still your best bet, because imagine if you need to do the minors and cofactor method. First of all, to get the determinant of this 4 by 4 matrix alone, you'll be there forever. And then you're done with that. You start looking for the minors, the cofactors, and all of those things. A whole lot of time. So your best bet is the Gauss-Jordan method in this kind of situation. So let's go to it. So using the Gauss-Jordan method for inverse, you already know that the first thing you do is you have the matrix given, and then you augment the matrix with the unit matrix. Of course, it's a 4 by 4 matrix now. So you have to augment with the identity matrix for 4 by 4. That's 4 by 4 unit matrix, which is 1 0 0 0 1 0 0 0 1 0 0 0 1. I mean 0 0 1 0 and 0 0 0 1, like that. So, and the idea is that, having started with this M now, and this augmented it with this I, at the end of the day, wherever M is, this M becomes a unit matrix, and the unit matrix automatically becomes the inverse of M. That's the whole idea of the Gauss-Jordan method. And so we embark on the journey. Let's go. So the first thing I'm doing here is this. The idea of the Gauss-Jordan method is that at the end of the day, you have only elements along the principal diagonal. You have one all through along the principal diagonal. Every other thing has got to become 0, That's the idea, of course, and that's how to make that a unit matrix. And as you do that on that part, it also transforms this one into the M inverse at the end of the day. So that's what we are going to do. And of course, my method for doing this is this. You can do it anyhow you like, but my method is to make sure you take it column by column. So first of all, we are going to focus on column 1, and the pivot is the elements of course, the pivots are always along the principal diagonal. So the pivot for column 1 is this one here in row 1, column 1. So, and the easiest way to handle this is to make everything below it. Everything has got to be 0. So you want to make everything below it 1, so it can be easy to subtract. So the first step I'm taking, you see, the old one is still the new one. The old row 2 is still the new row 2. But because this is 2 now, and it's easier to make it 1 for easier subtraction, so I want to make that 1. So that's why I multiply through by half or divide through by 2. That is, multiplying through by half is the same thing as dividing through by 2, by the way. So divide through by 2 or multiply through by half. So that's why the old row 3 multiplied by half becomes the new row 3, and the old row 4 remains. Since 2 is the only one that has the issue. But if these ones were not 1 and this is not 1, so you'd have had to do something about them to make them 1. You would have multiplied by their multiplicative inverse to get 1. Okay, so if that is the case, we just transform. So R1 is R1. So we just repeat 1, 2, 3, 1, 1, 0, 0, 0. Then R2 is R2, 1, 3, 3, 2, 0, 1, 0, 1. Then half of R3. So half of 2 divided by 2, 1. 4 divided by 2 is 2. 3 divided by 2 is 3 over 2. 3 divided by 2 again, 3 over 2. 0 divided by 2, 0. 0 divided by 2, 0. 1 divided by 2 is 1 over 2. And 0 divided by 2 is 0. So that's all we have to do as the first step. So now you have R4 is R4, so 1, 1, 1, 1, 1. Every other thing goes like that. So the next thing we want to do is to turn all these to 0. You want to turn all these ones to 0. And the way to do that is just subtract, just say each of those rows minus 1, minus the row 1, and then you go. So for row 1 now, row 1, the old row 1 remains the new row 1 because it's the pivot and it's already 1, so we don't have to do anything about it. So this remains what it is. And then the new row 2 now is going to be the old row 2 minus the old row 1. So that's 1 minus 1, 0, 3 minus 2, 1, 3 minus 3, 0, 2 minus 1, that's 1. And then you go ahead to the other side. 0 minus 1, that's minus 1. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 0 is 0. And then the old row 3 minus the old row 1. So that's 1 minus 1, 0. 2 minus 2, 0. 3 over 2 minus 3, that's 3 over 2 minus 3 over 1. The LCM is 2. 2 into 2 is 1 times 3, 3. Minus 3, that's 3, minus 2 into 1 in 2 is 2. 2 times 3, 6. So that's minus 3 over 2. Minus 3 over 2. And that's why this is minus 3 over 2. So 3 over 2 minus 1. That's like 3 over 2 minus 1. 1 is like 2 over 2, right? So that's 3 minus 2, 1, all over 2. And that is why this is half. Then next one, you have 0 minus 1. That's minus 1. 0 minus 0, that is 0. Then half minus 0, you have half. And then 0 minus 0 is 0. And then the next one is row 1. Row 4 minus row 1. Row 4 minus row 1. So for row 4 minus row 1, you also take those values as they come. So row 4 minus row 1 is such that you have 1 minus 1, 0 here. 1 minus 2 is minus 1. 1 minus 3, that's minus 2. 1 minus 1 is 0. 0 minus 1 is minus 1. 0 minus 0, 0. 0 minus 0 again, that's 0. Then 1 minus 0 is 1. So with that, now you can see that everything here is 0. So everything below the pivot for the first column is 0. So as far as column 1 is concerned, we are good. So the next thing we are going to do is to shift our attention to row 2. So for row 2 now, this is row 2. For row 2, the pivot is at column, for column 2 rather, the pivot is at row 2. So interestingly, this is already 1. So if it wasn't already 1, you have to make it 1. In fact, you have to make everything 1 so that everything below, this one above it and every other thing below will have to go to 0. Interestingly, this is already 0. So the only job you have to do is to turn this one to 1, turn this one to 1, so it can be easy to subtract from this one. So, and following that now, it means you have to take half of the whole of this because this is 2. That's for row 1. For row 4, multiply this by minus 1 so that this one can be minus 1 can become 1. And that's exactly what we are going to do next, as you can see here. So for row 1, we say half of old row 1 is a new row 1. Then row 2 remains row 2, row 3 remains row 3, and old row 4 multiplied by minus 1 gives us new row 4. So if you take half of this now, half of everything here, so that's 1 over 2, 2 over 2 is 1, 3 over 2, 1 over 2 again, 1 over 2, and every other thing is 0. Then row 2 is what it was, row 3 is also what it was, and row 4 now just multiply by minus, so you have 0, minus 1 times 1 times minus, that's minus 1, minus 2 times minus 1, that's 2, 0 times minus 1, that's 0, minus 1 times minus 1, that's 1. Then 0, 0, then of course this is also minus 1. Okay, so now it's very good that we have for column 2 now, the pivot is 1 and everything below. So this is already 0, so we don't have to bother. So this has to go to 0 and this also has to go to 0. So it means you have to subtract like that. So what do? We say the new row 1 is going to be the old row 1 minus the old row 2. And that is why old row 1 minus the old row 2, that's half minus 0. We have half up here. 1 minus 1, that's 0 up here. 3 over 2 minus 0, that's 3 over 2 up here. Half minus 1, that's minus half up there. Then half, this half again, minus 1, that's half plus 1. And you know 1 is 2 over 2. So 1 over 2 plus 2 over 2 is simply 3 over 2. Then 0 minus 1 is minus 1. Then, of course, you have 0, 0 if you subtract like that. Row 2 remains row 2. The old row 2 is still the new row 2. The old row 3 is the new row 3, all right? And then for row 4, it's the old row 3 is still row 3 because this is already 0, so we don't have to worry about that. Then the new row 4 is going to be the old row 4 minus the old row 2. So 0 minus 0, that's 0. 1 minus 1, 0. Then 2 minus 0 is 2. Then 0 minus 1, that's minus 1. And then 1 minus minus 1, that is 2. That's 1 plus 1. Then 0 minus 1, that's minus 1. Then 0 minus 0 is 0. Minus 1 minus 0 is minus 1. Okay? So with that, again, column 2 is settled. So our focus is shifted to column 3. So now we need to think about column 3. So this is column 3. So for column 3, the pivot is on row 3. Okay. So, and as we know, everything has got to become, so everything below it and above it has to be 0, right? So, but of course, the first thing we have to do to make that easy is make sure everything is 1 first. So for easier subtraction. So, and that is why, from what the numbers you have there, you know what to do. So we want to make this 1. So it means we have to multiply row 1. So the new row 1 is going to be the old row 1 multiplied by 2 over 3. The old row 1 multiplied by 2 over 3 will give you the new row 1. And that is why 2 over 3, 2 over 3 times half, that's 2 over 3 times 1 over 2. 2 cancels out, so you have 1 over 3. 2 over 3 times 0, you have this 0. Then 2 over 3 times minus half, that is, 3 over 2 times 2 over 3, that's 1, as usual. Then minus 1 over 2 times 2 over 3 is minus 1 over 3. Then 2 over 3 times 3 over 2 is still 1. 2 over 3 times minus 1 is minus 2 over 3. Then 2 over 3 minus times 0. So you can see that 2 over 3 times 0 is 0. So 2 over 3 times 0 is 0. 2 over 3 times 0 is also 0. And then row 2 remains row 2 because everything is in order already. So row 2 remains row 2. Now for row 3, now this one has to be 1, 2. So the multiplicative inverse of minus 3 over 2 is actually minus 2 over 3. So multiply everything here by minus 2 over 3. So minus 2 over 3 times 0 is 0, times 0 is just another 0. Minus 3 over 2 times minus 2 over 3 is 1. Minus 2 over 3 times half is minus 1 over 3. Minus 2 over 3 times minus 1 is 2 over 3, Minus 2 over 3 times 0, 0. Minus 2 over 3 times half, that's minus 1 over 3. That's minus 2 over 3 times 1 over 2, right? This cancels out, so we have minus 1 over 3. Minus 2 over 3 times 0 is also 0. Then for row 4, right? For row 4, we take half of that because here we have 2. So we need to make these 2 into 1. So divide the whole of row 4 by 2 or multiply by half. So 0, half times 0 is 0. Half times 0 is also 0. Half times 2 is 1. Half times minus 1 is minus half. Half times 2, 1. Half times minus 1, minus half. Half times 0 is 0. Half times minus 1 is minus 1 over 2. So again, column 2, column 3 is such that everything is 1, but then this is the pivot, so everything below and above it has got to be 0. So we can now just subtract correspondingly. So what do? We say the new row 1 is going to be the old row 1 minus the old row 3. So that is 1 over 3 minus 0, that is 1 over 3. 0 minus 0, that is 0 here. 1 minus 1, that is 0. Minus 1 over 3 minus 1 over 3. That's minus 1 over 3 plus 1 over 3. That is simply 0. Then 1 minus 2 over 3. That is 3 over 3 minus 2 over 3. That's 1 over 3. Then minus 2 over 3 minus 0. That's minus 2 over 3. 0 minus 1 over 3. That is 1 over 3, right? 0 minus 1 over 3. That's 0 plus 1 over 3, which is 1 over 3. Then 0 minus 0 is also 0. So that's done. So the old row 2 is the new row 2, no problems. The old row 3 is also the new row 3 because we already have 1 here as pivot. And then the old row 4, I mean, the new row 4 is going to be the old row 4 minus the old row 3. So that is 0 minus 0, we have 0. 0 minus 0 again, that's 0. Then 1 minus 1, we have 0. Then minus 1 over 2 minus 1 over 3. That's minus 1 over 2 plus 1 over 3. So that's LCM 6. 2 in 6 is 3. 3 times minus 1, that's minus 3. Plus 3 in 6, 2. That's minus 1 over 6. So that is why this one is minus 1 over 6. Okay. So the next one you have 1 minus 2 over 3. That's 3 over 3 minus 2 over 3. That's simply 1 over 3. Minus half minus 0. That's minus half. 0 minus 1 over 3. That's 0 plus 1 over 3. That's 1 over 3. And minus half minus 0 is minus 1 over 2. Again, we are done with that. So the next thing we have to do is to consider column 4. Column 4. So that's where our attention shifts to, column 4. And for column 4, right? See what we have? For column 4, the pivot is at row 4. So, and that the value there right now is minus 1 over 6. So we have to make that into 1. And of course, everything above it has got to become 0 at the end of the day. But first of all, we make everything into 1 for easier subtraction. And that is why we have this next set of rules. Okay. So we have okay, of course here it's not necessary to do what we have to do, but we know at the end of the day this has got to be 1. So we can as well just do that now instead of waiting till the very end. So just to make this one 1, we just multiply through by 3. So 1 over 3 times 3 gives us 1. So we just do that around all that. So 3 times 1 over 3 is 1. 3 times 0, 0. 3 times 0, 0. 3 times 0, 0. 3 times 1 over 3 again is 1. 3 times minus 2 over 3 is minus 2. 3 times 1 over 3 is 1, okay? Then 3 times 0 is 0. So that is settled. The old row 2 is the new row 2, no problem. And then for the old row 3, we want this one to be 1. So we have to multiply by the multiplicative inverse of minus 1 over 3, which is minus 3. So minus 3 times 0 is minus 3, is 0. Minus 3 times 0 is also 0. Then minus 3 times this, minus 3 times 1 is minus 3. Then minus 3 times minus 1 over 3, that's 1. All right. And then minus 3 times 2 over 3 is minus 2. Minus 3 times 0 is 0. Minus 3 times minus 1 over 3 is 1. Minus 3 times 0 is also 1. Then for row 4, now this is minus 1 over 6. So we multiply through by minus 6. So this one can be 1. So we have minus 6 times 0, 0, 0. That's 0, 0, 0 here. Minus 6 times minus 1 over 6 is 1. Then minus 6 times 1 over 3, that is minus 2. Then minus 6 times minus 1 over 2, that is 3. Minus 6 times 1 over 3, that is minus 2. You know, minus 6 times minus 1 over 2, that is 3. Like that. All right. So we have made everything there into 1. So the next thing is with this pivot now, this and this have to be 0. Thankfully, this is already 0. So let's go and do that. Okay, so and the way to do that is to say everything minus row 4. Everywhere we need to have 0. So we just say that row minus row 4. So row 1 is already settled, so no problem. We are done. Then row 2 is not settled yet because we have 1 here. So we just say row 2 minus row 4, and that becomes the new row 2. So 0 minus 0 is 0 here. Then 1 minus 0 is still 1. Then 0 minus 0 is 0. 1 minus 1, 1 minus 1 becomes 0 here. Purpose achieved. So minus 1 minus minus 2, that's minus 1 plus 2, that is 1. Then 1 minus 3 is minus 2. 0 minus minus 2, that's 0 plus 2, which is 2. 0 minus 3, that's minus 3 here. Then row 3 minus row 4 is the next thing we have to do. So 0 minus 0, that's 0. 0 minus 0, another 0. Minus 3 minus 0, minus 3. So 1 minus 1 is 0. Okay? And then the row 4 is row 4, no problem. So we have row 4 as usual. So now it looks like everything is almost done, except that in Gauss-Jordan form, we are doing row reduced echelon form. We need this to be in row reduced echelon form. And that means that all the leading entries, all the elements along the principal diagonal should be 1. So this is the only thing we have to do now. So it means that we have to multiply row 3 through by minus 1 over 3 to make this into 1. And once we do that, we are good to go. Okay, so Gauss-Jordan requires us to reduce, to have the matrix in row reduced echelon form. So we go now and just say, row 1, the new row. Oh, okay, so this is my mistake. This should be, this should actually be row 1, right? So the old row 1 is still the new row 1 because that is already settled. The old row 2 is the new row 2, settled also, and then the only issue is with the row 3, where this is minus 3. So you multiply by minus 1 over 3. So if you do that here, 0, 0, you have 0, 0, 1, 0, 0, minus 1 over 3 times this, that's 1. Minus 1 over 3 times 3, that's minus 1. And then minus 1 over 3 times this, that's also 1. So with that, everything is done, and row 4 is the old row 4 is the new row 4. So the old row 4 is the new row 4. So with that done now, you can already see that this is a unit matrix, while this automatically will have to be the inverse. Okay, so this is the inverse of that matrix. So you can just go back and make your conclusion that so the inverse of the matrix is given as M inverse, which is equal to 1 minus 2, 1, 0, 1 minus 2, 2 minus 3, 0, 1 minus 1, 1, minus 2, 3 minus 2, 3. Just like what you have already seen, that is what we just got, right? That is what we just got. This is the inverse. 1 minus 2, 1, 0, 1 minus 2, 2 minus 3, 0, 1 minus 1, 1, minus 2, 3 minus 3, 2, 3. That's the inverse for that 4x4 matrix we started out with. I mean, this 4x4 matrix now, this is the inverse, of this 4x4 matrix. So the other part says hence or otherwise solve the following system of equation. I'd rather go with hence, meaning that from what you have done, getting the inverse now, solve that system. So since this is the inverse now, so we want to solve the system of equations. To solve the system of equations, we can use the matrix inverse method because we already have the inverse. So it is easier to just use the matrix inverse instead of trying to reinvent the wheel. So to solve the system of equations, we can use the matrix inverse method such that if you put all the coefficients, you end up getting the matrix you started out with. Then of course you have to multiply that by x1, x2, x3, and x4. And now all you just need to bring is this the answers, the right answer, 5, 11, minus 6, and 7, and that is like mx multiplied by b. And to get your x now, it's simply take m to the other side and it becomes m inverse multiplied by b. You already have m inverse, so you just put the m inverse here. So this is m inverse, that is just your m inverse now. So this is m inverse multiplied by b, and that is what is going to give you your x. So you have a 4x4 matrix. This is 4x4 multiplied by a 4x1. So of course this is possible because you end up getting a 4x1 matrix, which is okay. So, and how do you do that? Now, since you have 4 rows here, you have to write this one out 4 times. And that is exactly what we are going to do here. So write it as 4 times. So you have 5, 11 minus 6, 7, 1, 5, 11 minus 6, 7, 2, 5, 11 minus 6, 7, 3, 5, 11 minus 6, 7, 4. And then what do? You go back to each of those rows. Go back to each of those rows. The first row is 1 minus 2, 1, 0. You have 1 minus 2, 1, 0. The second row is 1 minus 2, 2 minus 3, 1 minus 2, 2 minus 3. The third one is 0, 1 minus 1, 1, 0, 1 minus 1, 1. And the third one is minus 2, 3, minus 2, 3, minus 2, 3, minus 2, 3. So it's tidier now. So the next thing is just to add add, multiply and add. So 5 times 1 is 5, minus 22 here, minus 6, then 7 times 0 is 0. So, and then the next 5, minus 22, minus 12, minus 21, you have that. Then next you have 5 times 0 is 0. 11 times 1 is 11. Minus 6 times minus 1 is 6. 7 times 1 is 7. And lastly, you have minus 10, plus 33, plus 12, and plus 21. So with all that sorted, you can then go ahead and add up like that. So 5 minus 22 is minus 17, plus 6, that's minus 23, plus 0, that's minus 23. Then 5 minus 22 again, minus 17. Minus 17 minus 12 is minus 29. Minus 29 minus 21 is minus 50. Then 0 plus 11 is 11. 11 plus 6 is 18. 18 plus 11 plus 6 is 17. 17 plus 7 is 24. Then minus 10 plus 33 is 23. 23 plus 12 is 35. 35 plus 21 is simply 56. And that is your answer. So how do you know if this answer is correct? You can test them in the original equation to know. So of course, we know that x1 is minus 23, x2 is minus 50, x3 is 24, and x4 is 56. How do you know that you're correct? Just go back. For instance, I remember that the last one says that x1 plus x2, plus x3 plus x4 is equal to 7. So is that correct? Minus 23 minus 50 is minus 73. And then so 24 plus 56 is 80, that's 80. 80 minus 73 is 7. So that's correct. So you can try the other ones and you discover that it's actually correct. So with this, you have done justice to that problem. So so once you have more than 3 by 3 matrix, don't bother using any other method apart from Gauss-Jordan, where you augment the matrix and turn the matrix into unit matrix while the unit matrix turns into the inverse. So that's how it is in this case. Make sure you have, if you have not subscribed, be sure to do that. And press the notification bell so you can always get alerted whenever I make a new video. See you again. Thank you for listening.